given this problem statement, so here set S is given and y belongs to this closed interval minus pi 2 pi, and it will not accept any value of the form pi over 2, that is positive and negative pi over 2 is not included in this particular closed interval, right? Now this y is constrained by this given equation, that is sine of y times tan y plus tangent of y, that is equal to sine of 2 times y. So if t is represented by the summation, that is summation y belongs to set of S, that means whatever value of y has to be picked up, it has to be picked up from this set S, and then we'll use this expression cosine of 2y to compute the summation, right? Once this value of t is computed and the number of elements is computed within set S, we need to compute the sum of this, right? That is t plus number of elements present in set S. Now let us proceed towards the solution. So if you observe, this is the equation. So first of all, we need to get this equation and convert this set from set builder form to roster form, that is listed form, and then from the list we can just plug the values and get the sum for t. And once we have the list form, we can also count the number of elements present in set S. So this equation is the primary part here. Now if you observe one thing clearly, so from this equation tangent of y is common, right? But before that, let me just convert this sine of 2y in the form of tan. So this can be written as 2 times tan y plus 1 plus tan y squared. Now if you can observe here, this tan y is the common factor, and this is sine y plus 1, that is equal to 2 plus, sorry, this one I can just replicate this one as it is, right? Yes. Now here from this we can say that tan of y will be equal to 0. That is one of the equation, right? And the other equation will be, if I just eliminate this tan y for the next part, right? So sine, so I'll just maintain a gap over here. So considering that I am cancelling out this particular part, that is tan of y. So if I cancel out this part, then I need to consider the value where tan y becomes 0, and I need to get the separate values for y from this one. Similarly, sine of y plus 1, this can be written as 2 times this tan of y is already taken care of, and we know the identity, that is 1 plus let me just mention the identity, that is 1 plus tan y squared is equal to secant of y squared, right? So now I'll be applying trigonometric identities on this one and resolve this equation further. But before moving to that, let me just resolve this part. So from this we can say that y can accept these values, that is negative pi, 0, and then positive pi, right? Because it is already mentioned in the problem statement that what are the values that y can accept, right? So it is mentioned within this. Now this tan of y is equal to 0, this was something that is taken care of, and I got these values. So later when I'm treating this entire equation as a whole, I'll consider these three roots as well. Now I'll be solving this part step by step, right? Now on using this identity, instead of this 1 plus tan of y squared, I can replace it by secant of y squared. Now with this 2, 1 is multiplied definitely. So 1 is multiplied with any number, any real number, right? So 1 over secant y squared, this can be written as 2 times cosine y squared, right? And now I can convert this into similar terms, that is instead of this cosine squared y, this can be written as 1 minus sine of y squared. Very simple. We know the reason, that we know this reason very well, that sine squared y plus cosine squared of y, that is equal to cosine y squared is equal to 1. So now on solving this equation, right, so I'll just replicate this one, and on solving this equation we can write this one as 2 times sine y minus 1 times sine of y plus 1, that is equal to 0. Just check once. Yes, it seems correct. Now from this one, we can write that sine of y is equal to 1 over 2, and the other value is, so I can say that sine of y will have to belong to these values, that is, one is 1 over 2 and the other value is negative 1. Now this negative 1 has to be rejected, right? So I can say that this sine of y that is equal to negative 1, this part will get rejected actually. So this has to be rejected. Correct. So what is the reason? Reason is very clear that for y we have already mentioned that what are the values of y that is acceptable. Correct. Now this is, if this is rejected, then definitely we can say that sine of y is definitely equal to 1 over 2, right? Now if that is the case, then from this we can say that y will belong to this set, that is minus pi over 6, sorry, pi over 6 positive, and then the other one would be 5 times pi over 6. So these are the acceptable values, and it's very obvious that why some of them got rejected, some of them got accepted. So I can just jot down this particular reason that is given in the problem statement itself. So finally we can say that, therefore S belongs to, these are the elements. So initially we got these as the acceptable elements for S, right? And then the other ones are these two. So from this definitely we can say that the number of elements present in set S is equal to 5. Now we need to compute, so let me just remove this part, right? So now in the next part I need to compute this particular value, that is t. So now we'll compute this part. So it's given t as this, so I'll compute this part now. Now here this one can be written as cosine of negative 2 pi, that is negative 2 times pi over here, plus cosine of 0, because cos 2y is given, right? And then plus cosine of 2 times of pi, and then plus cosine pi over 3, because this 2 will multiply with pi over 6, so that becomes pi over 3 here, right? So cosine of this, and then this will be 5 pi over 3, 5 pi over 3, and let me just substitute these values now. So this value will be 1, plus cosine of 0 is 1, this is again 1, and cosine of pi by 3, that is half, and again this is also half. On computing this, I will get the number as 4. So for this, the number of elements present in set S is 5, and for this t I got the answer as 4. So now finally I will be writing my final answer. So here this is the expression that was demanded. So let me just replicate this. So the value of t we got is 4 and the value of s that we got is 5. So therefore 9 is the answer for this problem statement. So 9 is the answer for this given problem statement.